Hello class, this is Mr. Carlson, and they've added a few questions to the homework since I made the original videos, and so I wanted to make a brief supplemental video to answer a few extra questions. The chapter we're going to look at is Chapter 2, Section 5, so 2.5, so let's go ahead and click that. Now the first one says use graphs to solve linear equations, and so we'll start there. And what they have are a question where it says use a graphing calculator to solve the following linear equation. Now, in my opinion, you should just solve this the regular way just by solving the equation. Simplify both sides, solve for x, that's fine. It's going to be tricky for me to teach you how to do this because everybody has a different graphing calculator. But let me go ahead and show you how to do this really fast with let me show you how to do this real fast with an online graphing calculator, just so you get the idea. So there's more than one way to do this. However, the way MyLabs Plus wants you to do it is they want you to start by simplifying and moving everything over to one side. So this is 6x minus 9x, which is negative 3x. And then if we subtract 4x over, we get negative 7x. So if I went too fast, just do it for yourself. The idea is we want to make one side of the equation be 0. So I move the 4x over. So it's 6x minus 9x is negative 3x minus 4x is negative 7x. Now let's do that for the numbers. We have 9 minus 8 is 1. And if I subtract 8 over, it'll be 1 minus 8, which is negative 7. So that would then equal 0. And then we replace the 0 with y. And that's the equation that they want us to graph. So we put the entire equation is equal to 0, and we replace the 0 with a y, and you'll see why in a second. So what I'm going to do now is go to a website called Desmos.com. It looks like this. It's an online graphing calculator website that's free, and I highly recommend it. It's desmos.com, and then just click the graphing calculator button. And you can see we get this great graphing calculator. So I'm now going to graph the equation. So y equals negative 7x minus 7. You can see that I just graphed the equation on the graphing calculator, so here's the red line. So every point on this line is a solution to y equals negative 7x minus 7. And you might be thinking, well, hang on, Mr. Carlson, the equation we were answering is 0 equals negative 7x minus 7. That's because we moved all the stuff over. Well, guess what? Here's what's really cool about algebra. You'll notice that the line does cross 0 on the x-axis. And notice it's negative 1 comma 0. That's actually the solution to the equation, because when you plug in negative 1 for x, that's what gives you 0 for y, and that's the equation that we graphed. And you could graph other things too, like if it was this negative 7x minus 7 is equal to 5, or 6, it would just be wherever it crosses at 5 or 6 or whatever. So in any case, because it was equal to 0, negative 1, 0 is the answer. Negative 1 is the x answer. And when you plug in negative 1 on into here, you get 0. So we'll just plug in negative 1, and that's the answer. So again, it was the x value. It was the x value of the point, negative 1, which was the answer, negative 1. That's the solution set. Hopefully that makes sense. I believe that's everything on here. And again, you're welcome to just solve this the regular way. It's nice to know how to use graphing calculators. This one asks us to solve, so let's solve it real fast. It'll be x is equal to 14, I think. See, when you do these 10,000 times like I have, you can do them in your head. So the solution set is 14. What minimum and maximum x values would it make it possible for the solution to be seen? Well, you'd need to at least go past 14. So you'll notice that, like for this example, the previous one we did, if I was way zoomed in, you wouldn't be able to see the answer. So you need to at least be zoomed out to where the answer is within the viewing range of the calculator. And so I think on this one, it needs to at least be between to 16. So I think we'll put A. Oops. Oh, see, again, that's so arbitrary. I guess they're assuming that your graphing calculator goes from negative 10 to 10, which that depends on your calculator. So that's a really dumb question. So that's why I missed that, and I'm sorry. I did not know that the standard calculator is negative 10 to 10. That is news to me. I also don't think that's true. What minimum and maximum values would make it possible to view the solution? This is the question I thought they were asking. The answer to this would be B, because it goes from negative 16 to 16, and the 1 means that the x increment goes up by 1. And so that's what you need to know for that. So, oh well, at least you now can get it right now that you saw me get it wrong. Hopefully that makes you feel a little better. So now you can at least get those questions right on the homework. But as I said, in my opinion, you can just solve them regularly. That's fine. Okay, there's one more question I'd like to answer for you. And that is solve applications involving equations of lines and linear models. So we need to use the formula for slope to solve these. And so it says the chart to the right shows the egg production on various years in this table. Use these points where x is 0 for 1994, x is 1 is 1995, and so on, and make an equation for predicting the amount of eggs that we'll have. So let's do that real quick, and this will be a little bit sloppy, I apologize, but I'll do my best. So it says use the points 0, 52.7, and 4, 61.1. So our 2 points our 2 points that we're going to use are 0, 52.7. Why is my font all strange? That's fine. Okay, so 0, 52.7 as the first point and 4, 61.1 as the second point. So those are the 2 points we're going to use to form the equation. Remember, we need to do y2 minus y1 over x2 minus x1 to get the slope first. That's what we'll do to get started to get the slope. So that means that m is going to equal 61.1 minus 52.7 divided by 4 minus 0. And that will give us our slope for the equation. So let's calculate that real fast. So it's 61.1 minus 52.7. Then hit enter, and then we need to divide that by 4 minus 0, which is just 4. And so we get m equals 2.1. Okay. Now we can use the other equation of y2 minus y1. Or actually, I remember it's big Y minus little y equals m times big X minus little x. And that's how we can get the equation. So I'm going to pick the first point. Whatever, I'll pick the second point. So that's going to be y minus 61.1. You get the same answer either way. Equals 2.1 times x minus 4. So now we just need to solve this for y. So do the distributive property. Leave the left alone. Y minus 61.1 equals 2.1x minus 8.4 by distributing the 2.1. And then we just need to add the 61.1 on both sides. And so we'll get y equals 2.1x plus, and then we just need to do this calculation real fast. So this calculation will be 61.1 minus 8.4, so we get 52.7. And hopefully that's the answer. Y equals 2.1x plus 52.7. Fantastic. So that's how you get the equation. I just used these two formulas, which you should write down on a cheat sheet. The two formulas being the slope formula and then the point slope formula. Now it says, what is the predicted egg production in 2000? That means use the equation to find out the answer for 2000. So 0 is 1994, 1995, 96, 97, 98, 99, 2000. So the number we're plugging in for x is 6 because 2000 is x equals 6 based on how they've listed the data. So let's do that real fast with our calculator. So 2.1 times 6 plus 52.7. And again, that's just plugging in 6 for the x right here to get a y value of 65.3. Okay, so that's the prediction. And so you can see that that's kind of close. The table actual amount was 70.3, and our line predicted 65.3. So we're a little bit less than what the actual amount was with our prediction. So it says, how does they compare? It's less than the actual figure, and to find out how much less, we need to subtract. So 70.3 was the actual amount minus our prediction, which was 65.3, which is just 5. And if you subtract them in the other direction, that's fine. If you get -5, that's fine. I think because it's saying less than, we should put it in as a positive answer. So we'll see if I'm right or not. The result is 5 billion less than. I think you'll get it wrong if you put in -5. I think you should just put in 5. Okay, so that's how you do this problem. Make sure you're very careful on which points you're picking to actually do the question. The one I'd like to show you is one that involves doing a regression equation. And in order to do this, you need to have technology. So I'm going to show you this question now. And again, you have to use technology to do this. So I'm going to show you how to do it on Microsoft Excel. And then I'm going to show you a website, if I can find one, that you can do if you don't have Microsoft Excel. Okay, so here's our data. And once again, they're saying x equals 0, x equals 1, x equals 2 for every year. So what I'm going to do is open up Microsoft Excel. And so for the x values, I'm going to put them into the left column. So 0, 1, 2, 3, 4, 5. So that represents 2013, 14, 15, 16, 17. Okay? Does that make sense? Now I'm just going to put in the numbers for the other column. So it's 24,591, 25,762, 26,764, 27,970, and 29,471. And why am I off by 1? I guess we only have 0 through 4, so I'm going to delete that 5. Okay, so there's the data. I just typed it in from the problem, except I put in 0, 1, 2, 3, 4 as the numbers for the years, and they told us to do that. Okay, here's what you do next. On Excel, you highlight the cells by just clicking and dragging. So I'm just clicking and dragging to get those 5 points. Then you're going to click Insert, and there should be a tiny little button that says that's a scatter plot. And a scatter plot is just a graph with a dot for every point. So you can see I have it right here, and you're just going to pick the scatter plot. And so you can see now I have it on Microsoft Excel. I have the 5 points. Now what you're going to do is you're going to right-click on one of the points. So I just right-clicked on the point, and you're going to click Add Trend Line. Okay, so I just clicked on Add Trend Line, and here's the next step. You see down here it says Display Equation on Chart. First off, make sure that you're on linear. It should be on linear automatically. And then click Display Equation on Chart. And now I'm just going to close this options menu. And you can see that they've added the equation right there. And it might be a little hard to read. Maybe I can make it bigger. I can't really. Oh. Okay, there you go. So you can see that they put the equation. And what the computer has just done, actually, is a set of very complicated math that figured out the perfect line that goes through these 5 dots that minimizes the vertical distance between the line and every point. So it involves some very complicated math, and luckily the computer just does it for us. And so that's how you get the equation to type into the answer. So the equation is y equals, remember y is the same as f of x, I'm going to type in 1196.8 plus 24518. Why didn't it work? Oops, it didn't work because I left out the x. See, everybody makes mistakes. It's okay to make mistakes. I left out the x. So let's try that again. 1196.8x, because that's the slope, plus the intercept of 24518. So let's try that now. It's still wrong. Do I have an error? If it's still wrong, the most likely culprit is an error in typing in your data. But I don't see an error there. Use integers or decimals. Round to the nearest hundredth. I'm not sure what's wrong. I'm just going to round to the hundredth just to be silly. I'm not sure what I did wrong. Because I typed in all the data correctly. Oh, I know what I did wrong. I jumped straight to part C instead of doing part A. So I'm not going to remake the video because this is a good learning experience. What I just did for you is how to answer part C because I got ahead of myself. So the reason I got this wrong is because I just did part C. So I'm going to leave the equation up here. You can see that in part A, they wanted me to use these 2 points. Okay? They wanted me to use these 2 points. And so that's what I'm going to do now. So once again, if I had done, m, if I had done m equals, y2 minus y1 divided by x2 minus x1, if I had done that with these 2 points, 0, 24591 and 4, 29471, if I had done it with those 2 points, just like we did the previous problem, and then if I had done the equation big Y minus little y equals m times big X minus little x with one of the points after solving for m, then you would have gotten this equation. So I apologize for that. I got a little ahead of myself. Let's just keep going, though. If you have a question, please contact me. Graph it on the same coordinate axis. So here's where we can use Microsoft Excel. You can see that the graph should kind of look like this, except that they're playing with their axes. So this is bad practice because the y-axis does not start at 0. As you can see, my 2 axes both start at 0, but they start at 24,000. That's really bad practice, and so once again, MyLabs Plus is not good. However, we can see that the slope is positive, so it's either going to be B or D. And what's the difference between B or D? I'm going to make them a little bigger. This one starts above 24,000, so that looks good, and it finishes below 30,000, so that looks good because of these 2 numbers, the 24591 and the 29471. This one, wow, that's a really subtle difference. That's a very, very subtle difference. What's the difference here? I see that these 2 points are a little below the line. Oh, I see what they've done. They've shifted this over 1 to start at 1. Do you see that? They've shifted this to the right 1, starting it at 1. But this one, they actually start at 0. So that makes B the correct answer because they started at 0 for this one, whereas here they started at 1. So I was trying to find a difference between the points up and down. What they've done is shifted one of them to the right one. Anyway, so the answer is B. And so it says nice work. And what does the slope indicate? Because the slope is going up, it means that tuition and fees are increasing. And the amount that they're increasing is equal to the slope of the line. So I'm just going to put 1220 here because that's the slope from part A. So a positive slope means it's increasing, a negative slope means it's decreasing. Now they want the predicted cost for 2016. So the predicted cost for 2016, we use the equation. And for 2016, it's going to be 2013 is 0, 2014 is 1, 15, 16. So we plug in a 4 here for x. So let's do that real fast. We'll plug in a 4 for x. Whoops, sorry about that. I grabbed the wrong calculator. So 1220 times 4, enter, plus 24591. Again, that's just plugging in 4 for the x right here. I get 29471. I'm not having a good day. (2013) is 0, 2014 is 1, 2015 is 2, 2016 is 3. Sorry, I got it. I was off by 1. So 2013 is 0, 2014 is 1, 2, 3. I should have plugged in a 3. Sorry about that. So it should be 1220 times 3 equals plus 24591. This is why it gives you extra chances, right? Right. So I'm modeling how you should be solving your questions when you're working on the homework. Let's try 28251. Okay, finally we got it right. So compared to the actual value in the table, 27970, you can see that our prediction from the equation is a little bit high. So we would say that the approximation is our choices are more than double or slightly greater than, because it's not less than, so we can eliminate those two. I wouldn't say that this is double, right? It would have to be like 56,000 to be double. So I'd put slightly greater than as the answer. Okay. Here's the equation of the line of best fit using technology. So this is the part where you have to go through that thing with Microsoft Excel. And so here is where we need to put in the equation from Excel, which is 1196.8, and then the intercept is 24518. And that's how you answer that question. So I apologize again for getting ahead of myself. Hopefully that makes sense on how we answered eventually all of the parts of this. And if you have a question, please email me. If you do not have Microsoft Excel, then let's see if we can find a website where you can do this. So I would just type in linear regression calculator, and let's just see what comes up. So this says the first option is GraphPad. Excellent. So this is going to work just fine. So I just literally just Googled it, went to this website called GraphPad. You just need to type in all of the numbers, just like Microsoft Excel, into this program. Let me see if I can copy it from Excel to save some time. Oh, you're kidding me. Did it not work? Oh, it did work. Fantastic. So I just copy pasted the numbers. You can just type them in. Leave these as X and Y, and that's fine. And click Calculate Now. And again, it's doing some fairly complicated math in order to solve this. And so you can see that here it gave you the graph of the dots and the line. This is called a single multivariate linear regression, in case you were wondering. And the part that you need to care about is the slope and the intercept. So let's see if it gives us the equation. Beautiful. Again, oh no. It's off by a little bit. Darn it, I think this thing rounded. Did it give us a choice for... Do you see? I think they rounded it, so we're not going to get it right. Because, whoops, we got 1196.8. So the intercept is correct, but they rounded it. I wonder if there's a way... That's really dumb. Okay, we're going to try a new calculator. Let's try this one. I think this one is going to work better. So I'm just going to type in the values. Just going to type in the values here. So 0, enter 1, 2, 3, 4. Don't press enter after the 4 or it might mess it up because it'll think there's a final value. Now I'm going to type in 24591, 25762, 26764, 27970, 29471. Okay, we don't need to put anything in the estimate. Just put in the x's and the y's and click calculate. So there again, it gave us a graph. Please tell me you didn't round. Beautiful. There's the equation right there. It's that y hat, which is the typical symbol you use for a regression equation, is y with a little hat on it. So I recommend using this one because they didn't round. Everything else you can ignore. You'll learn about that more in a statistics class if you want to take a statistics class. And so, but there's the equation, 1196.8 times x plus 24518. So please use the one at social statistics. That looks like it's a better, the socialstatistics.com quick linear regression calculator. It looks like that one's a little bit better. Again, I'm leaving all this in the video because I want you to see how you can solve these equations and find good tools by using Google or Bing or whatever search engine you like, or DuckDuckGo. And to see that this is a process, right? This is a process. So I think it's valuable for you to see my process in solving these. Okay, all of that being done, I think that's it from the study plan that I wanted to show you. Let's go back to the study plan. There was one more that involved doing temperatures. And again, you just need to create your 2 points. So here it says when the Celsius temperature is 35, the corresponding Fahrenheit temperature is 95. So that means when you're doing this for your 2 points, because you're trying to find an equation for both of them, the first point would be just pick an x and a y. And because they want the equation as F equals, I would do the Fahrenheit as the y value. So the Celsius temperature is 35 when Fahrenheit is 95. So that would be your first point. When the Celsius temperature is 75, the Fahrenheit y value is 167. So there is your 2 points, and from there you can use the slope equation and the point slope equation like the first example that we did to find the equation. Okay? And same thing on this last example. It's just here is 2 values for x1 and y1, and here's x2 and y2. And from there you should be able to find the equation using the slope formula and then the intercept formula. So I do apologize that this video was a little bumpy. I hope it makes you appreciate the other videos that are a little less bumpy, because on many of them I had to do multiple takes to try to smooth the process out. So please let me know if you have any questions, and good luck on this study plan. I will talk to you later. Bye-bye.